Hi, everybody. How are you doing? What time is it? We started 50 after,
Yep.
So I reckon we've got until 40 after to...
Yep.
It's too much time. You know why it's too much time?
Why?
We're using Spring and the Tanzu Platform.
Yeah, that's
Way too much time. We don't need that much time. I'm Josh Long. Very nice to meet you all. And this is my friend and colleague back from the old Pivotal days. He's a pivot like me, ex-pivot alumnus. Adib Saikali. Is that?
That's right. You got it right.
I know how to spell it. I've known how to spell it for like a decade. I just don't. I never trust myself with anything.
No,
more
you got
than
the pronunciation perfect.
A single syllable, and I fall apart. You know. So anyway, this is you're in the Great White North, right? You're in Canada.
I'm in Toronto.
Oh, such a nice city. And I'm here in the States, and one of the you and I have been talking about these technologies together for years and years and years to every customer that'll listen. And I got to tell you, I feel like sometimes the platform side gets a little, because it just works and there's not really new, like everybody needs to run things conveniently, you know what I'm saying? It's always interesting to me there. And actually I wrote a book about this. This is a book I wrote way back in 2017. Don't buy it. And the reason you shouldn't buy it is because while the Cloud Foundry discussion is still, everything works exactly the same, right? The Spring Boot version, well, I mean, there's new stuff obviously in Cloud Foundry, but the Spring Boot stuff is all about microservices. And today, I don't know if that's your necessarily default go-to architecture. You know, maybe it's not. And also, this is Spring Boot 1.x, or maybe it's 2.x, but it's certainly not 4.x, right? And so this book is called Cloud Native Java, and it's a book on designing systems with Spring Boot, Spring Cloud, and Cloud Foundry. And the book was written about, moving quickly. I care about moving quickly. I care about agility. You and I used to walk the pivotal walk, right? We used to talk about how to get from zero to production as quickly as possible. So this book is called Cloud Native Java, and one of the things that is a kind of a rite of honor for people writing books for O'Reilly is the selection of the animal on the cover. So this is a blue-eared kingfisher. This bird is a bird that is native or indigenous to the Indonesian Java Islands. And so it's a bird that is native to Java, and birds, they fly. They fly often through clouds. So you would say that this is a cloud native Java bird, okay? It's an actually amazing picture. So I love this book because of that, and I love the book because I look back and all the stuff on Cloud Foundry, it still makes 100% sense today. And actually, I think this is before, we've kind of gone full circle, haven't we?
Yeah, I mean, there's some pretty cool stuff we'll show you today.
Oh yeah, of course. I mean, that's what I'm saying, but the utility of it has been obvious to anybody who's seen it every time we've talked to anybody in the last 10 years.
Well, yes, and now with AI agents, it's a lot easier to drive.
Right, and
your agents can use technology like this much more easily than they can use fairly complex, potentially in-house things that have a lot of configuration settings.
And that's just it, right? Like, there's been a whole surge of Kubernetes-based platforms, and we've come out the other side, and guess what people are building? They're trying to build something that looks like a Cloud Foundry, which we had as early as 2011, right? Like, people want simplicity at that layer. If you're spending more than a few minutes getting an app to production, you've got your priorities wrong, right? It just is. It's just wrong. You're not focusing on the thing that is. We used to talk about business differentiating value, and so one of the things I love about Cloud Foundry is that it lets me feel like because there's nothing worse than going to work and spending all day buried in YAML.
You feel like 10 years younger?
Yeah. Maybe that's why I do it. Just to revel in the old days. No, there's nothing worse than going to work and wallowing in YAML trying to get something deployed, right? You've done nothing. You've achieved nothing, right? All you've done is revel in YAML. And I just feel like that's a very sort of terrible way to treat yourself. If you want to feel good at the end of the day, that should be your last step. So I like Cloud Foundry because you don't have to do that. It's just you get something up and running very, very quickly. So today, we're going to spend about, a fraction of a few seconds talking about Spring and Spring Boot and Spring AI. I'll set up an example here. Some of you, how many of you have had the dubious pleasure of having been to one of my talks today? Oh, so sorry. So we'll quickly go over an example just to because I think we're being recorded, and I want to make sure people get the use case there. But the really interesting thing is not writing the code, because anybody can write interesting code with Spring, right? Even that's the whole point. If I can do it, certainly all of you could do it. What's interesting, what sets the good engineers from the great apart is their ability to get that thing into production. And we're going to show you a cheat code today, like how to do that quickly. Can you talk about Cloud Foundry, or do you want to talk about that later?
Yeah, I'll talk.
Just the history.
I'll do that later.
Okay.
Let's get everybody going.
Okay.
And then I'll be able to do it better in context.
Sure.
Of actually showing you how it all works.
So we've got the code for all this stuff here, and I'm just going to walk you through it all. I'm not going to type it all out live. You can. No, what have I just done? That doesn't make sense. Here we go. Clone. Git clone. So this is a sample application. Yeah. Computers. Please. There we go. So the code is there. Who's torrenting? Somebody, please get off the internet. Oh, this is so awkward. What? I've never had a Git repository go so slow. Okay, I was only half joking. Who's torrenting? Okay, here we go.
Could be all of the recent troubles that GitHub has been having.
Oh, poor thing.
Yeah.
They need Cloud Foundry. Okay, here we go. So we've got this one added as a Maven project, this one as a Maven project, and this one as a Maven project. Okay, so we've got 3 applications here today, and the use case that I've been talking to people basically all day about is, hey, let's build an application using Spring AI. Spring AI, I'm utterly convinced. And were any of you in the panel that Adib and I participated in with the good, the great, the amazing Dr. Rod Johnson and Kevin Strumheier earlier? In that conversation, I think you could see that the thrust of our conviction is that Java is not just a palatable, option that's on par with what you've got in the other ecosystems. It's provably, markedly better, and it's not close, right? Many, many orders of time faster. It takes as few lines or lower than most of the other languages and ecosystems to write the same code. It has just as rich an ecosystem, and it is more secure, more observable, etc. So this stuff is, it's really, really interesting to see. And so in order to demonstrate that, we have a little sample application here that supports adopting dogs from a fictitious dog adoption agency called Pooch Palace. And this application, AI applications, are integration applications, right? The name of the game, as with so many interesting things in the world, is assembling different things and reusing them, repurposing them as quickly as you can. So Spring, of course, makes that naturally very, very trivial because we have this portable service abstraction, right? If any of you remember the original Spring training that we used to do back in the old days, we used to talk about the Spring triangle, right? Spring triangle. And that triangle included dependency injection. It included portable service abstractions. And it included aspect-oriented programming, or AOP. I should have aspect-oriented programming. Normally you do the abbreviation in the parentheses first, don't you? There we go. Okay, and you can see all the stuff in play with Spring AI there. And one of the levers that Spring gives you to move quickly from one implementation choice to another, from one model to another, from one data source to another, is the rigid use of interfaces and polymorphism. So for example, here in my application, I have the chat client. The chat client in turn, where's my chat client here? The chat client in turn needs a pointer to the vector store. There could be any number of different vector stores on the class path or on in the bean context. There are many different implementations of this interface, but it doesn't matter because we can write all of our code in terms of that vector store interface. Likewise, when we use the chat client is going to talk to a model, and that's expressed in Spring AI, an LLM model, an AI sort of large language model. That chat model interface is the foundational interface upon which all this is based. So that portability is useful, and it makes it so that you can easily switch if you need to, and you can think in terms of local and or maybe you've got like a model that you want to bind to, but for whatever reason you need to move away from it. And that's actually I have a lot more charity for that position than I did for people who said they wanted to have the portability for data sources. Right? I don't know about you, but
I just have a question for the room. Who here has written an application that calls a model?
Yeah.
Like an AI model? Just one hand, okay.
Oh, so we'll talk about that in a second.
Okay, so a lot of you are probably new to that, and you're wondering, like, how easy is that to do? I'd say that all of you are experts already at calling models.
Yeah.
Because raise your hand if you've written client code to call a REST API.
Yep.
Okay,
Done.
pretty much everybody, right?
Right.
It's pretty much what it is. Like when you call the models, you're calling a REST API. It just happens to be that each of the AI labs has their own proprietary REST API, unique to them. OpenAI has their own REST API, Anthropic has theirs, Google has theirs. It can be a little bit painful as a developer to be like, why am I learning the same thing 3 times? This is where I really appreciate what's available with Spring AI, because you only just have to learn it once with the Spring AI portable abstraction, and you can use it everywhere.
Yep, 100%. And you will see in the AI world that portability buys you leverage that you don't necessarily have, I think, or need. Well, people who said they have more than they want to move to a different database. How many times have you seen that?
I've only credibly seen it when people have a H2 for their testing, right. And like some other database for production.
Right. But in the AI world, it's very common to have small models for certain use cases, to have, at the same time even, you might have a small model talking for routing or whatever, and you have a more heavy but also more intelligent model for deeper sort of analytics and things like that. It's very common to have multiple models, or indeed to switch from one model to another because things are changing so quickly in the space. It's not uncommon to build an app last year that works just fine against the model against which it was built, but that would do better against a new model. And that portability is of value, right? And it'd be nice, of course, if you didn't have to recompile your program to get some of that portability, and we'll talk about that.
And there's also cost.
There's cost, yeah, huge.
Like switching model providers can actually give you something that's cheaper. Or my favorite one is that there's like an 80% cost difference, for example, between distilled models like, say, GPT-4o Mini and the actual full-blown one. Sometimes, like, how do I test my application against multiple different models to find the one that actually gives me the highest price-performance ratio?
This is not like a hypothetical. I guess what I'm trying to say is that those foundational things that were in Spring 25 plus years ago, they are a huge force multiplier in today's fast-moving world, right? And so Spring AI brings that to the fore, right? These patterns serve you well. So in this application, we're injecting the chat client. We're making a call to the AI model. We're passing in the question that the user's asked. It's just a string. That's called a user prompt. In fact, this is the chat client experience for most people, right? You get the chat client. If you want to build the chat client, you inject the chat client builder, right? And just like the REST client.builder, right? Or just like the web client.builder, or the JDBC client, although there's no builder for that one, right? And you just chain together this fluid DSL to arrive at a correct response. And here we're saying we want to make a call to this endpoint. We've configured a parameter that will be used in augmenting or enriching the memory for this conversation. I'm basically saying that this conversation should be ascribed to a particular user. That user we're of course deriving from the Spring security context holder, the thread local in effect for this particular application, holding the current authenticated user. And it's just pretty straightforward stuff. I'm not going to spend too much time talking about this. Goodness knows I've done so today. This is the client, and it's possible that this client might be asked to answer questions about when it might when the model might recommend that the user so enamored with a particular prospect dog that they might want to come into the clinic and adopt a dog. And that might happen. And if that happens, we want that model to be smart enough to forward that request to this tool, this MCP tool written in Java as well, running on another host and port. And Java, by the way, again, this is super important. Java is a really good fit for these kinds of integration use cases, right? Here's this amazing benchmark. You saw this, of course, but like, has your LinkedIn stopped becoming like? It's been a month of people posting this benchmark. Is that true for you?
Yeah, it's been pretty interesting. Speaks to a little bit of like the classic value prop of the JVM.
And what's surprising to me is that people were surprised.
Yeah,
right. That's what blew my mind. When I saw this, like, well, duh, like we've been telling this to people. Here's a benchmark that compares the speed, not the alacrity with which it's written, but the actual runtime speed of MCP frameworks. And so it looks at Java, in this case using Spring AI. It looks at Go, Node.js, and Python. Okay, and if you look at where's the results and analysis. Here's the performance metrics summary. So the Java implementation has an average latency of less than a millisecond, right? Whereas the Python one has like 26, almost 27 times more latency, right? And by the way, latency is not the same as throughput, and the throughput is much better in Java as well. So here we have 1,624 requests per second for a total of 1,559,520 for Java. Go comes in second, pretty close, right? 0.855 versus 0.835. It's a slightly better P95 latency, and it does about the same throughput, right? And then these two languages, the less said about which the better, of course, but Node.js, right? Literally an order of magnitude worse than Java, right? And about a third as many requests total achieved, right? Same thing for the RPS. Python, it's like, why would you? And by the way, the framework they're using in Python to implement their MCP service is called, can you guess?
I think it's called Fast MCP.
Which is so ironic. It's very ironic.
I think Fast probably for productivity is what they're...
But it's not. It's even there. It takes less code in Java. So, okay. So it's not good. Resource utilization, right? Java is the worst for memory, but if you use GraalVM, that goes way down. And every other way, it's better. It's less CPU than Go, way less CPU than Node and Python, right? Latency, I mean, these two, and then these two. And Java's got the better story here, right? So, I don't know. I guess what I'm trying to say is it's important to be production worthy. It's important to be fast. It's important to be secure. And so we're using MCP. We're building an MCP service here. Using the JVM, this MCP service is going to return information, and it's going to be authenticated. Well, where does that authentication come from? It comes from a token that's been sent by the MCP client in the request. In my local demo here, have a Spring authorization server. And this is not to do with anything, it's not specifically to do with anything related to AI. It's just good old OAuth. Didn't you write a book on OAuth?
Yeah, I did. I may have.
Well, what's the name?
It's called Securing Application Security for Developers.
Ooh.
It's on Manning, and it'll be out shortly.
It's still not done?
Yeah, COVID mistake.
No. Oh.
It's taken a while.
I was going to say, didn't you start that
during COVID, yes.
So the only space that even comes close to moving as quickly as AI is security. So I don't envy you your task there. I read some of it years ago. I thought it was well past published already.
But it's taken a while.
Oh man, okay.
It's in the final stages.
Okay, I will be expecting a copy for my birthday, please.
You will.
I didn't say which year. Just whenever you can.
Yeah.
Okay, so we've got an auth server here. I'm a terrible person. I've got some in-memory users. Obviously, this is not secure, right? You can see my password. It's just PW, right? But it's a trivial auth server. The only customization I've done is I've specified a client, right? An OAuth client here called Spring, I called it default client. and it's got a default secret for the client secret. I've specified a redirect URL, which is the URL to which the auth server should redirect after the request has been authenticated. And then I've specified some customizations here for the, this is from the amazing Spring AI community, right? Spring AI community, MCP-security project. So Spring AI community is a GitHub organization in which we have projects that are moving a little bit quicker than perhaps we can afford to commit to in the main Spring AI repository. Lots of great stuff here though, right? Like lots of great stuff. I wanna, here, let me do that incognito so I don't show anything I shouldn't show. Okay, there we go. So we've got like, you know, a judge framework, super useful, a sandbox framework, super useful. Let's see, different models that we couldn't support directly in Spring AI proper, but for whatever reasons, licensing or geofencing or whatever. The agent client support, so if you want to orchestrate things like Codex and Cloud Code and whatever from the Java universe, you can do that from Java and orchestrate these things. There's even a protocol called ACP, Agent Client Protocol, I think. There's like 3 of them, but I'm talking about the one that means Agent Client Protocol, which is a protocol for controlling coding agents like Cloud Code. There's the agent utils, which gives you the ability to, among other things, bring in skills, the new thing called skills. How many of you have heard about agent skills from Anthropic? And if you haven't, I don't blame you. It was literally released in February. So, you know, don't worry, it's fine, but we have support for it, full support for it in Spring AI already. And of course, here's the aforementioned Spring security support. This is basically how do you secure communication between one MCP service and another, right? So all that is there, and all I'm doing is I'm using that aforementioned security. And by the way, you can get that, you can easily configure that if you go to start.spring.io, choose MCP security, model context protocol security, experimental, and then, you know, if you're doing an OAuth client, configure OAuth client, look at the build, and you'll see it's already configured the OAuth Spring AI Starter MCP client, right? MCP client security, right? And if you choose resource server, go over there, you'll see it brings in MCP, nope, that's wrong. Do I have to remove that maybe? There's this, resource server, MCP client security. What did I do wrong? MCP server, resource server. Oh, there we go, that's what I forgot to do. Yeah, that's the trigger. So there, MCP server security, right? So you just add in whether you're on the client side, you add the MCP server or client, and then add this, and it'll add the right module for the security for that particular thing.
And
so, yeah.
I was just going to say for everybody, if you want to dive into the gory details of MCP security in particular, Joe Granja from the Spring Security team has a talk on this topic tomorrow. So
really?
Sure, yes.
Oh, yeah.
He's going to give you all the low-down details.
Perfect segue.
So, yeah.
See, we planned that. Let's just say that. Anyway, all that to say, all I'm doing is I'm customizing the default behavior of the auth server by adding, in this case, the dynamic client registration, which is very useful if you want to consume a MCP service from, you know, Claude desktop or what's that one you like, Goose?
Goose or Codex.
Codex or whatever, right? So okay, I guess we should just start these things up and let's see it working. Okay, got my auth going. Got my assistant going. And by the way, the assistant is, where is it? This is this one. It needs a connection. I happen to be using OpenAI, okay? And you need to specify an API key. Well, of course, I'm not going to want that in my source code, so I've set up an environment variable, right? You want to extricate configuration that's environment specific from the code. That's just, you know, 12-factor apps, that kind of thing. So I've got this environment key that it's already specified. I've got this environment variable rather, and Spring Boot, you know, will convert that into the property here. So Spring AI, OpenAI API key. But this is the kind of thing where people can get into trouble. Is you need to have a secure way to allocate and provision and link applications with models. You know, their credentials, that kind of thing. It turns out that OpenAI, so we have like more than 20 different models in the Spring AI's core, and then maybe another half dozen or so, whatever, in Spring AI community. But even if we don't support the model that you want to use on all those implementations, we support OpenAI. And that's become a kind of de rigueur, de facto standard. Just like the S3 protocol is now the de facto standard for blob stores, not blob, blob stores, right? Things that you can store bytes in on the cloud, right? Lots of other vendors, though they are not S3, they support the S3 protocol. Same thing for OpenAI. So I'm using OpenAI here, which is, I'm actually using OpenAI, but I found out last year that there was a lawsuit with the New York Times, right? And the New York Times the judge ordered that OpenAI preserve all the logs of all the conversations going on with OpenAI so that the New York Times could do discovery. So in effect, so that they could sift through the logs and see if the models generated anything that would infringe upon their content. Well, if you're an enterprise, if you're a bank, I don't know that that's going to be okay with you, is it? Doesn't feel like it is. Probably not, right? So it's nice that it's a standard protocol, but maybe you don't want to use that. So we'll talk about that in a bit. But okay, standard stuff. Let's go stand this up here as well. Okay, there's the scheduler MCP. And I'm going to ask it some very simple questions here. 127.80.80, which port did I start it on? The assistant is on 8080. Ask, and I'm going to, I have to do URI encoding. Okay. I should just build a MCP for URI encoding. Okay, do you have any neurotic dogs? Right, I'm looking for my buddy Prancer. Actually, what dogs do I have in the database here? I've got a bunch of dogs here. Is that it? That's
You can try it, see what it says.
Yeah.
I think it worked earlier today.
Okay, well, let me see. Okay, go over here. I've got a bunch of dogs here. Let me just check. That is so sad. What did I do? Oh, is it because I have...
Oh, we tested it on the
platform, yeah.
Maybe you can show it there.
I have a thing here, reset. Where am I doing that? If the vector count is 0, find all vectors. But what if it's not 0? Okay. And then... So did that kick in? I don't know. Let's just reload the assistant.
Well, you could always make the request to the ones you already deployed.
True.
Then I can.
You want to skip? Okay, yeah, we could do that. Can I just see if this works? I just want to see. Question equals that. Oops, I didn't copy the encode. Come on, go over here. Go over here. 127.80.81. Ask question equals that. Oh, it's 80.80. Okay, redirects me. Asks me to redirect back. And of course, it doesn't. I don't know that it has any dogs, so it's not going to get very far. So it'll probably give me a bad answer here. Okay, good. It's offering to help me with that. And then we can say, when can I have to encode this as well. So when can let's just pretend Fido from the San Francisco Pooch Palace location. Okay, URI encode. Okay, take that. Okay. Now, if everything goes to plan, that'll be an authenticated call to a downstream scheduler MCP thing. Waiting for the response here.
No.
There we are.
Well, try it against the one that's running on the platform.
Yep. Okay, no problem. It's confused. So now we go to the platform. Actually, do you want to? So this is. I've got an application. I forgot to provision the data and the dogs. It doesn't matter. I actually have this on the platform, and you can see my problem. I've got a database. I need an LLM model. I've got to have a vector store. There's a lot of use cases here that require some care, and I haven't taken that care. But I'm not going to be able to get to production without it. Should I scoot over?
No, it's okay. I got it. I can reach over. Okay, there we go.
I can. You okay?
Yeah, I'm good. I'm good. Let me just change the settings here and make the text a bit bigger.
So considerate.
I know these.
It's the end of the day. People have weary eyes.
Okay. 960. How's that for people? Everybody can see that, or is that
Enormous. Yeah,
that's better. Okay.
Wow.
All right. So one of the things that we want to be able to do is to deploy these things to production. And when we want to deploy them, the challenges we run into are many. So let me first show you where this is running. And we go here. So remember those three apps that he had? The assistant, the authentication, the authorization server, and the adoption scheduler. Those were on his machine, and they require certain services. So one of the nice things is like, hey, for the case of the code over here in the assistant, we needed a way of getting our hands on an OpenAI key, right?
Yeah.
So the main problem we have is if you want to provision something in the enterprise, typically you get asked to open a ticket. I don't like tickets. Do you like tickets? Do you like waiting? Nobody does. So instead, what you do is you have the ability to create services. So in this marketplace here, let's go down and you'll see that we have this thing called the GenAI solution. And here are a bunch of models that exist. So for example, let's say I'd like to talk to GPT OSS 120 billion parameter. I can just simply select it. We'll just call this one test for fun. And I'll put it in Josh's space. And I'm going to say create. So what happens now is I'm provisioning access to an AI model that is hosted on the platform. But I could also have provisioned access to an Anthropic model or a Gemini model or an AWS Bedrock model. Because what we're doing is that we have a piece of middleware. That piece of middleware is able to receive requests using the Open AI API, and it will translate those to whatever is the target. And of course, this thing, we call it like the AI server. It's actually built with Spring, using Spring AI. And it's part of the platform, Tanzu Platform here. So if I click on this one here, you can see show a couple of things. One is I can for example, create a service key. Let's call this one test. What this is going to do now, if I view it, is, and I'll delete this after, so you won't be able to use the key. But this is basically going to be like, hey, in your Spring AI, you could use this URL right here with this API key. And that would give you access to that particular model. And this is really helpful because you can actually change the models that you have simply by changing the configuration of this. So one of the big things that we believe in is the idea that as a developer, you should just be able to declare your intention. And the platform that you're deploying your application on is the one that owns fulfilling that intention. So if we go back here to our marketplace and then we go down to this platform here, you can see all these models. Well, where did these come from? Well, the answer is show you a little bit of what the administrator would have had to do. So the administrator would have had to go in here and you can configure all of these plans. So these are, for example, where was it? We were using the 120 billion, there we go.
And that's the open source, OpenAI model, basically.
Yes, that's the
recently.
OpenAI. Yes, so it's a recent one, but this one is actually deployed on this platform directly, and you can, this one is running with GPUs.
So it's air-gapped and secure and private. Nobody sees the data. You don't have to hand it over to the New York Times.
I mean, it's, like, this is running in one of our colleagues' basement. He's gone a little bit crazy on buying GPUs and hardware, and so
he's the one.
Yes, this is Nick's lab, right? You can see it up here, like it's his home lab, and the idea here is that when you're building these things, you don't care as a developer where the thing is running. You can let the platform take care of providing you with access to the AI models. You can let Spring AI take care of adapting and offering you a consistent interface for accessing this, okay? So that covers like one small piece of that. So let's actually go here, and we will go back and go to.
And you're showing right now the Tanzu Platform, and that's based on Cloud Foundry.
Correct.
Cloud Foundry is an open source platform as a service. You could, as you can see, Nick is deploying it in his own infrastructure at home, in his basement. But this is used by, well, it's the worst kept secret. I mean, it's like every major organization you've ever heard of probably uses it. Like it's everywhere.
Yep. So that's kind of one view on that. Now the other thing that when we look at the app, you'll see that in this case the assistant app is connected to the chat model, but it's also connected to the embedding model, because you need an embedding model to do RAG, and that's what this application is doing. It also needs a vector store, and in this case it's using PG Vector, which is also coming from the same platform. So all the components you need, framework, models, databases, all comes from the same place, same experience. Right? So I want to show you a little bit more stuff of what can this allow you to do in the real world. So I'm going to switch here to a little bit of a case study. So this is something we do on the Tanzu engineering team. So in our organization, because we're a software company, we do a lot of builds. Every day we're doing 27,000 builds. Sadly, about 2,500 of those fail. What happens when the build fails in your organization? Do you just hope that the next one passes and you just ignore it for a little bit? Raise your hand if you do that. Right? But sometimes you have to go investigate. Every time you go to investigate why the build has failed, that causes you some fatigue because you are probably in the middle of something else. And now like somebody's saying on the chat, the build has failed. The other problem is if you have a large software company, people move between teams. Every time people move between teams, you lose a little bit of knowledge on how they did things.
Can I?
Yeah.
I just realized. How many of you know who a Tanzu is? Okay, so there's Broadcom. How many of you know Broadcom? They're a chip company. They bought VMware. Part of VMware is a division called Tanzu, and we on the Spring team most of us who work on Spring, obviously it's an open source project, so there's innumerable many contributors from without, but most of the core people that get paid to work on it happen to be part of Tanzu, right? This is our team.
So what we wanted to do is we wanted to automate this kind of build failure analysis. And so what we did is we built what's called like a dashboard powered by Spring AI that can tell you, hey, it's constantly analyzing the builds that failed, right? So for example, as a developer, you can see here that you get like root cause analysis of why something happened, what's the root cause, and then like what's the evidence that backs up that root cause, and what's the suggested fix. Anybody have like any build analysis agents in their orgs today? Anybody built? No. Who would like something in your org where anytime a build fails, there's an agent that analyzes why it failed and comments and helps you?
Yes, auto remediation.
Yes. So, because that's the next step, is having the agent actually fix the build. So I kind of showed you that, sure, like it's real world. We've been using it for maybe 2 months now. But this was built, the engineer that built that, of course, with Spring AI. So this is kind of the architecture of how you could put together like this type of agent. So in this case, like we have two types of build systems. We have GitHub Actions, and then we have something called Concourse. That's something Pivotal created a long time ago. And so whenever there's a build failure, something ends up and it publishes a message to RabbitMQ. Anybody use RabbitMQ here?
All the time.
Yeah, the common messaging system. And so there's a Spring Boot app that says, okay, I've detected a build failure. So what I'd like to do is analyze it. So that goes to a Spring AI powered application. And that Spring AI application is going to analyze the log. So it takes the raw log, but how many people here have really giant logs with just a lot of noise? Right, so what do? You basically say, well, let me not give the model a gazillion lines of text, because that's going to cost me a lot of money, because it's going to consume a lot of tokens. So what it does is does a whole bunch of smart filtering, figures out like, okay, where's the failure? Maybe it finds a place where there's the exception. And then it says, well, I'm going to check to see if I've already seen this multiple times in this log file. Kind of finds the unique error messages. And then it goes, let me take a bunch of the log files just before the failure, the messages, and just after. And then that is what it does the AI analysis on. And from that, it gets like a structured output. So one of the really nice things about Spring AI in particular is you can tell it that you want JSON as output, not just raw text. And Spring AI takes care of configuring the communication with the model to get the model to generate JSON instead of plain text. Now, what do you do with all of that JSON that comes out? You stick it into a database, of course, right? So you stick it into Postgres, and that's what allows us to, kind of get to something that looks like that.
That's so awesome.
Any questions about this? Right? So this is an example of something. Now, this analysis obviously requires a model. Where did we get the model from? Remember that GPT OSS 120 billion that I was showing? That's what we're using. Because, like many organizations, we have a lot of really strict requirements around what AI models we can and we cannot use. But should we want to switch to a different model, new one comes out tomorrow, no problem. So this component right here is this AI server. That was the piece that was actually sits between your applications and the models. And it acts as the translator. It does a bunch of other really cool things for you. For example, it can log all of the requests that are going back and forth. In case your company wants to basically be like, we're not really comfortable yet with AI agents or apps that are talking to, presenting stuff to our customers, we want to record everything that goes through in our own database, and that's what this would allow you to do. That's the AI server allows you to do that. You might want to do things like you could be sharing a bunch of GPUs, and you don't want one application to take up all of the capacity of those. So one of the things that you can do with this is the ability to put rate limits on what's consumed, right? But the last kind of really cool thing that this does is, anybody have any requirements? Does any PII data scrubbing in everything you do?
Oh, yeah.
Or like you have your AI generate a response, you want to check that there's no PII data going to the model or coming back from the model. You want to make sure there's no foul language, that kind of stuff. The challenge with those is there's like an infinite number of ways that you can do it, right? I don't know what your company trusts for PII data scrubbing. I don't know what tool you trust for detecting bad language in responses that might be going back to customers. So what this allows you to do is this piece up here. It allows you to catch the traffic that the app has sent, but before it sends it to the model, it can route through your own services. So there's like a pluggable architecture for you to direct that traffic to a service of your choice that you trust for PII data scrubbing or whatever it is. Response comes back and it returns it, right? So those were like a couple of AI related things. But now I want to show you a little bit more like what happens, like what do you have to do to actually deploy this? Well, the answer is you just have to write a tiny little bit of YAML. And you can see an example of that here for the assistant. It's declaring these are the services I need access to. It's declaring that it needs Java 25. And these are just the Spring AI settings just to know where its other services are, right? So I'm going to switch a little bit and talk about another thing that you might be interested in related to Java and platforms in particular. Has anybody here tried to make Java start up faster?
All the time.
Anybody here played with Layden, Project Layden, heard of Project Layden? Anybody heard of AOT caching in Spring? Okay, so let me switch to a different one here. I'm going to show you. Yeah?
Is it a plugin in the pipeline, or do I add it in the manifest or in this file?
So is your question, how do I get Tanzu into for my Spring application? Yes. So Tanzu is an application platform, and you deploy that in your data center, like on your infrastructure, and then there you can actually deploy a bunch of apps. I'm just about to show you how to deploy an app. Is that okay? Give me a couple more minutes. All right. So what I'm going to deploy here is a different application. So let me start out, and in this case, what I'm doing is Now let me show you what my app does. So this is I have this repo where I try every single possible combination of things for settings. And this one I was experimenting with what are all the different ways to make my Spring app start up as fast as possible. And so there's this feature called CDS, class data sharing, that's been in the JDK for a long time. It has now evolved into called like AOT and laden in the latest versions of the JDK. And in order to use this feature, you need to do something called a training run. So during startup, your application is, the JVM runs and initializes the app, and then it saves a file to disk, and this file has the state of the application so that the next time you start it, it doesn't need to do a whole lot of the work that Java needs to do on every start. On every time you launch the Java virtual machine, it needs to do bytecode verification on all the classes it loads. It needs to do all sorts of things that could be avoided. And so in this case, let me show you what the app does. It is running over here. Let's, where is that? No, it's running over, let's go here to the Adib org. We'll go to Devnexus. Here's my application. Okay, so my app is very simple. It just shows codes that are randomly rotating, but those codes come from Spring Data JPA, right? So I have a database, and you can see here I've got an entity with the code. I've got a codes controller that returns a random code, and I have a codes repository with just a select statement that returns that. So the interesting thing about it is it's got Hibernate, it's got Spring MVC, and typically when you start launching these, you find that your application does take some time to find all of the entities, do all of the initialization work. So can we actually speed it up? The answer is yes, you can. In my tests that I've done, I see something like a 40% improvement. If you want like the latest numbers with the latest JDKs, a wonderful talk by Moritz, who worked on a lot of this stuff from the Spring Boot team that you can find on YouTube. And you can see just huge improvements.
Moritz Halberter, Halbritter, Moritz is his first name.
Yeah.
This is this 40% is increasingly important, especially in production, because it's, I don't know if we are the first to coin this, but the time to first token is important. Like how quickly can you be online answering questions is interesting and very important. And the faster you're up, the faster you're able to start.
So basically, in order to deploy something, only need one command, cf push. So what this is going to do, so you can see here, we just told it, this is the jar file where my code is compiled. I don't have to create a Docker file. It's going to run in a container. But I don't have to do any containerization. I don't have to write any YAML above and beyond this thing here that just tells it where my code is that I want to deploy. I'm telling it I'd like Java 25. There's a couple of things that I'm doing here that are interesting. One is I'm turning on Spring AOT enabled equals to true. What does this do, Josh? What does AOT do?
So did you know that Spring has a component model that exists during compilation? This is one of those things I don't know that people know about. Since Spring Framework 6 and Spring Boot 3, which came out in 2022 or 2023, one of those, since that version of Spring, we've had a component model that allows you to do code generation during compilation. And we, in fact, do that if you are using the AOT mode. And if you do GraalVM native images, for example, then you are using AOT mode. But it's also possible to do AOT without doing GraalVM native images. And we produce in AOT mode, we transpile your bean definitions. We actually go through the bean definitions during the compilation. So we actually create a sort of half-finished application context, a bean factory. We go through all the bean definitions, we do all the ingest, find all the beans via component scanning, we read in the old Spring XML files if you have them, please don't. We have bean Java configuration, all that stuff gets read in, and we create the meta model of all your bean objects, wire them together, and those bean definitions allow you to inspect those types and to do whatever you want with them. You can register AOT hints for GraalVM, and importantly, you can transpile the code. We can actually create imagine when you start up the program that you didn't have to do component scanning with reflection, didn't have to scan every jar and look for every resource file. Imagine if you could just skip straight to the fully realized and reified ready state of the application. Well, we write out that code during compilation in AOT mode. We write out that code in a separate class. So when you start up the program in AOT mode or in GraalVM, We don't do component scanning. There's no reflection. We go straight to the state of the beans as you want them expressed and configured, right? Yeah. We're not scanning your at configuration classes anymore and looking for methods with at bean on them and reflectively, because that's what happens normally. But in AOT mode, we skip all that. It's a lot faster. And
yeah, exactly. And that's really what we're requesting here. So when we did our deployment of our code, this goes through, and you're going to see here that it's going to do a training run, and you can see that it's going to optimize the application by creating an AOT cache. That's pretty neat, right? After which our application will start. If we go look at our at the logs for this application, let's go look at the logs over here. One of the things that we'll find in the logs is, is that it is using AOT. So if we search for AOT,
there you go.
See, you can see Spring Boot AOT will be enabled at runtime, right? And it'll just end up in a faster launch than it would have been otherwise.
Nice.
Right, question?
Are these files in the user folder or where do they reside?
So these files will end up in basically the container image that gets created when you do the CF push. And that's where you want them, because what happens with the training run is the version of the Java virtual machine that you run the training run on must match the version of the application that you run it with. And by doing it with like this technology, it guarantees that the two will match. You're never going to be like, oh, I ran a training run, but nobody used it. Okay? So last thing I actually want to show you is something interesting. So what happens if you have like a lot of these applications that are running? Well, you can do a bunch of stuff. You can basically have the platform automatically tell you where your CVEs are, so all the apps that are running on the platform. And if you want to kind of modernize your environment, actually, let me show you this one here. Is maybe more the cup of coffee for the people that are here. This will go and it will tell you, hey, I've analyzed all of these repos, and it analyzes them for how suitable they are to deploy in a containerized platform. It will tell you, like what are the modernization challenges you're going to run into, what are the technical facets that you would have to deal with, where the technical debt is, what languages are being used, so what versions of Java, what versions of Spring Boot, right? And it does more than just Spring and Java. So if you've got a large number of repos, this can really help you with modernizing stuff. Now, in the past, what's the number one excuse you've had for not modernizing things?
It's always been that way.
It's we don't have time, right?
Oh yeah, that too.
But there's a recent thing I heard about called coding agents. Maybe they have time. And so part of like operating in a fast way is to be able to do both of these things. So today we talked about a few things. Let me summarize it, and we'll be done. Number one, we talked about Spring AI and how you can use it to talk to any model. We talked about how you can take that and you can deploy it onto Tanzu Platform, and how you can get all of the models that you need, all of the databases that you need, and how you can activate some nice features like the ahead of time caching, AOT mode. And if you just do one thing after today, before you get back to home, please try AOT in Spring. You can find a lot of documentation in the docs on how it works, and this can answer your any criticisms you get from your developer friends that are not Java developers about Java being slow to start up.
Yeah. Thank you.
Thank you
for your time. Thank you, everybody. If you want cards, we've got some.